We live in a gravitational world, experience gravity in every moment of our life. Still, the answers to the foundation of gravity remains dubious. What defines gravity? And what is the cause of its existence? According to Newton, gravitation is merely a force between objects having mass, and mass is the quantity that resists force to produce acceleration. Newton gave a mathematical relation between gravity and mass. Wait! How come the quantity that resists force to produce acceleration is proportional to the quantity that produces the force itself? And this gives rise to constant acceleration for all bodies under the action of gravity. For Einstein, it's a loophole to understand gravity. Note that gravity is not only a single frame where acceleration of bodies are same. There's next to. Can you answer that? It's accelerated frame of reference itself. So here comes the postulate of general relativity. It says in the vicinity of any point, a gravitational field is equivalent to an accelerated frame of reference in the absence of gravitational effects. Let me show you what does that mean. I'm going to drop these two balls of different mass from a certain height. And here it goes. And this setup here will be my accelerating reference frame to imitate gravity in horizontal direction. This is fun. Let's do it. Now let's compare gravitational field with an accelerating frame. In both cases, objects experience no force and are constantly accelerating. And Einstein comes with an ingenious model of space-time of universe to explain gravity in terms of acceleration. First, what is space-time? Our universe is a three-dimensional spatial model with the dimension of time fused in it. This four-dimensional maze stores events from the beginning of universe to its end as static frames, and objects track a path in 4D space-time, just like the sun in the video tracks pixels and time correspondingly. Curving of space-time in coordinate concept means that the four-dimensional grids are not regular. Time runs at different rate at different point, and space-time is no longer uniform. Instead, it's stretched and contracted at different region, and objects track its straightest possible path in this curvature from one event to another. If you zoom close to this path in space-time geometry, you will see that it is composed of very tiny regions of flat space-time, like in free space, which are completely inertial, and are continuously placed in this curved geometry. No experiment whatsoever can distinguish these two nearby tiny local inertial frames. Thus, freefall seems inertial to falling objects. Space-time curvature works in this way. As time shifts in its axis, two nearby test particles track the straightest path in space-time geometry, which are inertial locally, called geodesic. But the track converges or diverges due to curvature, and gravitation is manifested in relative acceleration of test particles despite of non-existence of force.
Space-time and matter are fundamentally connected. Matter tells space-time geometry to curve, and geometry in turn is matter to move.
Space-time curvature is an awesome model to mimic gravitation, but it is more than that. And I believe gravitation is deeply rooted to the subatomic world, and it's our job to find it out. Thank you.